So in this video, we're going to look at complex numbers. So we just looked at imaginary numbers. Now we're going to look at combining real numbers with imaginary numbers. That's what creates a complex number. So when you look at 5 plus 2i, we can't add 5 with 2i because those are not like terms. One's a real number, one's an imaginary number. It's almost the same way we can't add, if this were 5 plus 2x, we can't add those together. They're not like terms. So this creates something called a complex number. And the standard form of that, or the general way we would write that, is a plus bi. And a is the real number, or just the number without I. And bi is the imaginary portion of this. Imaginary, what is it? I don't know how to spell that. Imaginary. Okay. I think that's how you spell it. Anyway. So that is all a complex number is. So when you hear me say complex number, it should always be a real number plus, or it could be minus, a number with I that's in it. So let's look at adding and subtracting complex numbers. So our final answer is always our real number first and our imaginary number second, or the I term is second. So if we look at number 1, we've got negative 11 plus 3i plus 9 plus 2i. So if I were you, I would go through and underline my like terms. I know negative 7 or negative 11 plus 9 is negative 2. Those are like terms. Our I terms are also like terms. We've got 3i plus 2i. So that's going to give me 5i. Actually, yeah. When I added them up on my paper, I got 6. I don't know. So that's how our answer is written. Make sure that you always put the I term second. Okay. Now let's look at number 3, because they're subtracted on number 3. The big thing with these you just got to remember is if there's a subtraction sign here, just remember that you're subtracting these like terms and not adding them. And you're also not multiplying. Just because these are in parentheses, they're separated by plus and minus signs, so don't multiply these. This is not the same thing as like fulling or anything like that. They just throw those parentheses in there to help you keep up with stuff. So let's look at number 3. We've got 7. That's going to be a like term with 2. So we're doing 7 minus 2. So that's going to give us 5. Then we've got negative 2i minus 6i, because the minus sign is going to go with this 6i. So just make sure you don't leave that out. And that will give us minus 8i. So that is our complex number that we would get out of adding those together. And really that's it for adding and subtracting. Not very complicated, not a lot of little tricks in there. You just got to keep up with their signs. Let's look at multiplying complex numbers. So you have to remember this. I squared, let me move it over. I squared is equal to negative 1. That's the big thing with imaginary numbers. It is like one of the 10 commandments. I squared is equal to negative 1. That's just one of the big keys to this. So when we're looking at number 5, we have 2i multiplied by 8 minus 3i. So we have to distribute this 2i to both of these. And that will give us 2i times 16, or 2i times 8, which will give us 16i, minus 2i times a negative 3i will give us minus 6i squared. And you have to remember that this portion here is equal to negative 1. So this is really going to be 16i minus 6 times negative 1. So we'll end up getting, and we flip this. You want your I term to go second. So we're going to rewrite this as this part right here, Negative 6 times negative 1 would give us a positive 6 plus 6i. So that's what it would look like when you're distributing them. Now let's look at actually multiplying two complex numbers where we have to use the full method. So if you remember, the full method is first, outer, inner, last. So when we look at something like number 7, these two are being multiplied. We've got 7 plus I multiplied by 5 minus I. So we're going to have to full these. And so we'll get 7 times 4, which is 28. That's the first. Our outer would be, let's see, I times negative I, which would be minus I squared. Then we would take the inner, which would be these two here. So it would be I times 4. So it would be plus 4I. And then we do the last, which would be, let's see, that would be this and that. Actually, I guess that would be the outer. Yeah, I did that wrong. So let me back up. It wouldn't matter. We'd get the same answer, but I did that wrong. All right, so we did the first. That's 7 times 4. Now the outer would be 7 times negative I. So it'd be minus 7I. Then we would do the inner, which would be 4 times I. So it'd be plus 4I. Then we would do the last, which is I times negative I. So that would give us I squared. So then we're just going to simplify this. So we've got like terms here, which is 28. That doesn't have a like term, so that's just going to stay. We've got negative 7I plus 4I. That would be minus 3I. And then this would reduce down to, or this would simplify to, because I squared is negative 1, minus a negative 1, which would become plus 1. So we're going to take 21 plus 1. Those are like terms. So we'd have 29, and we're left with minus 3. I on the end. So that's what it would look like when you have to FOIL them, which we should all be familiar with FOIL. You may just have to remind yourself a little bit about foiling. Now, for these examples, number 8, you're just going to FOIL that, and we'll do more examples of this, so I'm just going to skip it for now. Now, on number 9, we've got 6 minus 2I squared. When something's in parentheses like that and it's squared, that just means it repeats. So you're going to say take 6 minus 2I times 6 minus 2I, and then you would FOIL that out. And then if you have a situation like 10, where we have two complex numbers being multiplied here, so we would have to FOIL that first, then subtract that by what's left. So you're going to FOIL the inside of those brackets that I just created. Then you're going to take that answer and subtract it by the end piece, which we'll probably do an example of that in class, so I'm not going to do it right now, just so we can get everything and make this video pretty short. So that directly brings us to the next part of what we'll do with complex numbers. And that is, it's something called the complex conjugate. Now, the complex conjugate is just the opposite sign of whatever complex number you have. So the general form would be a plus bi. The complex conjugate of that would be a minus bi. Or if you look at 11, we've got 8 plus I. The complex conjugate would be 8 minus I. So pretty much it's just flipping the sign. And the two products of those are always a real number. So I'll show you what that looks like. So if we were to look at 11, we're going to have to FOIL this. So we're going to do the first, which is 8 times 8, so that would be 64, times the outer, so it would be 8 times negative 1, or 8 times negative I, which would be minus 8I, times inner, which would be 8 times I, so that's plus 8I, and then the last, which would be minus I squared. Now, if you'll notice here, negative 8I plus 8I is just 0. So that's going to cross out, and we'll be left with 64 minus I squared. We know that I squared is negative 1, so this is going to actually be 64 minus a negative 1, which is actually plus 1. So 64 plus 1 is 65, and that's our answer. So we're going to use that for dividing complex numbers, and I'll show you what that looks like. There's a certain way that you have to do these, so just be sure to pay attention to this. So in our notes, it says, watch out, I cannot be in the denominator. So just like we can't divide or take the square root of a negative number, we cannot divide by I. I cannot be left in the bottom of your fraction. So if you ever have I in the bottom of your fraction, this is what you have to do. So if the denominator is a monomial, meaning just one term, then you just multiply the top and bottom by I. But if your denominator is a binomial, you have to multiply by the conjugate, which is why we just went over that. So I'll show you examples of both. So on 13, we have 10 divided by 2i. We cannot divide by I, or we can't leave I on the bottom. So the way that we're going to get rid of that is divide the top and bottom by I. So then that will leave us with 10i divided by 2i squared. And that's what will help us get rid of this I on the bottom, because we know I squared is negative I, or negative 1. So 10i, this would simplify down to 10i over 2, and we replace I squared with negative 1. So now this is 10i divided by a negative 2, which if we divide 10 by a negative 2, that's just going to leave us with negative 5i. So that's how you would reduce a problem when your denominator is just a monomial. Let's look at when the denominator is a binomial. And that means our denominator is 2 terms instead of just 1 term. So when we have that setup, or we have that situation, you have to multiply the top and bottom by the conjugate. So on like number 17, we've got negative 2 divided by 5 minus I. The only way we can get rid of that bottom is to multiply the top and bottom by the conjugate, which it would not be 5 minus I, it would be 5 plus I. So we just flip the sign of whatever's on the bottom, and that's the conjugate. So we're going to do that to the top and the bottom. So when we multiply negative 2 times 5 plus I, that's what it would look like. We'll have to distribute that, and then on the bottom we'll be left with 5 minus I and 5 plus I. So these will get a little bit more complex, a little bit more challenging, just because there's a little bit more work. So on the top, we're going to distribute this 2 to 5 and I. So negative 2 times 5 is negative 10, and negative 2 times I is minus 2I. So that's going to be our top. Now, the bottom is going to be a little bit more challenging just because we have to FOIL that. But when we FOIL that, it would look like this. We would do 5 times 5, that's going to be 25, plus 5I minus 5I, and then it will be minus I squared. So the middle of that's actually going to cancel out. 5I minus 5I is just 0. So we'll be left with negative 10 over 2I divided by 25 minus I squared. Now, you always have to remember, I squared, we can replace that with negative 1 because I squared is negative 1. So this is going to be negative 10 minus 2I divided by 25 minus a negative 1. So that's going to actually be plus 1. So we're going to end up with negative 10 minus 2i divided by 26. Now, you're not done yet because this can reduce down, and I'm going to show you the best way to set that up to reduce it. So negative 10 minus 2i is the same thing, or divided by 26 is the same thing as saying negative 10 over 26 minus negative 2i over 26 as fractions. And you can reduce both of those down. So negative 10 over 26 will reduce down to negative 5 over 13 minus and negative 2 over I would subtract or would simplify down to 1 over 5, I believe. Or not 1 over 5. It would be 1 over 13. So as long as those have the same denominator, which it would be 1 over 13i, we can rewrite this as negative 5 minus 1 over 13. And actually it would be minus I over 13. And we're going to do, we'll probably go over an example of doing the full method with this. Because sometimes you've got to do the top, you've got to fold the top and the bottom, and it just makes it a little bit more complicated. But that is how you would multiply by the complex conjugate when you have I on the bottom. You can't leave I on the bottom. So if you have a monomial, you can just multiply the top and the bottom by I, like we did here. And when you have a binomial, you have to multiply by the complex conjugate. And we'll do more examples of